In this video, we'll talk a little bit about linear functions and primarily thinking in ratios to write models. Models are just fancy, is just another word for writing equations in our case. And in order to do this, we know we need two things. We need the initial value and we need the rate of change. Now, sometimes we can call the initial value, or you might have heard it called the y-intercept. I'm not going to call it that. I'd rather call it horizontal or vertical intercept, because that's where our function will begin on the vertical axis. Or sometimes this is referred to as the starting point, etc. There are many different names. Vertical intercept and initial value tend to be the most common that we'll use. Rate of change, now remember, sometimes the rate of change is constant. In reality, like when you go get gas, every gallon is going to cost you the same amount of money, but every, for example, year, a home probably will not increase by exactly the same amount. So that would be an example of an average versus a constant. Sometimes we call this a slope. Sometimes we refer to it as the average rate of change when we don't expect that things will change exactly by that amount every year, but we assume it will. And then constant rate of change where something actually increases or decreases by the same amount every single increase of the input. So let's take a look at an example and let's get modeling. A home in the Chandler, Arizona area was worth $120,000 in 2009. By 2012, the price of the home had increased to $140,000. Assuming the house will grow in price at a constant rate of change over the next several years, create a function that outputs the price of the home as a function of years after 2009. So we have the price and we have years. Those are the two variables we're comparing. And more specifically, price is a function of the years. And excuse me, I won't use y because people tend to think that that's the output value. So I'll just use P and T to represent years and the price. Okay, and then we want to explain the meaning of the initial value and the rate of change. So we'll get to this, but first of all, we've got to create a model. So depending on what kind of thinker you are, you might be best suited by starting with the table. So in a table, and you can draw it vertically or you can draw it horizontally, I'm just going to compare the input and output values that I have. So I'm going to look at the input compared to the output. I know that in 2009, which is my starting point because it tells me that we want to look at the home prices since 2009. But notice that it says the price of the home as a function of years after 2009. So rather than to start with 2009, we'll just call that year 0 because 2009 is 0 years after 2009. And this just makes our computations easier because now that we have 2009, we don't have to work with a gigantic number like this. We can just call it 0 to represent that particular year. Now this only works with time. It doesn't work with other things like distances, heights. You probably don't want to say a height of 2,000 feet is equal to 0 feet. But in the case of years, this is just our starting year, so we can call it year 0. The price we know was $120,000. So I'm going to make this in thousands, and that way I can just write 120. And then I know that in 2012, which is not exactly 1 year later, so it's a couple years down the line, and that would be specifically 3 years after 2009, the house is worth $140,000. Okay, so if I think about this on a graph, and here's my input and here's my output, I know that in year 0 we were at 120,000. So I'll just roughly call this 120. Then 3 years later, 1, 2, 3, the house was worth 140,000. I'll just say that's roughly here. And so we're going to assume a constant rate of change, so we're going to assume that every year it grows by the same amount. Okay, so we need to first of all figure out, well, what's it growing by each year? We already know that our price is found by starting at 120,000 to represent the first year. And is it increasing or decreasing? Well, it looks like it's going up, so we're going to add to that something, which we're going to figure out that something every year. Okay, so our rate of change is going to be, since our output is P and our input is T, our units would be thousands of dollars, because that's our output, per unit of input, which is year. Okay, well, let's figure out what that's going to be. So we go from 120 down to 100, up to 140. So this is an increase of $20,000. So you can